Hi, so today we're going to look at finding zeros that are both real and imaginary in polynomials. That is our goal. So to do that, so we're going to look at this function, and its q of x is equal to x to the fourth minus 3x squared minus 4. So in order to solve for zeros, we need to factor this. You get to decide how you want to factor it. There are a lot of different strategies. I'm going to choose one in particular that's going to use substitution, but that might not work for your specific function, so be mindful of that. So in our case, I see an x to the fourth and an x squared. I really don't want to factor an x to the fourth, that's pretty big. So what I'm going to do is I'm going to do a substitution. And between x to the fourth and x squared, the common factor is x squared. So I am going to choose a random value. You can choose whatever you want. Let's go g. G is equal to x squared. And then let's plug in all of them to confirm. So our function says x to the fourth, so that's going to be g squared. We also have a negative 3x squared, so that's going to become negative 3g. And now we're going to just plug in our values back in. So g squared minus 3g minus 4. And so this is actually going to be a lot easier for us to factor because it is a square and we are way more familiar with that. So let's start factoring. So I see that my g has no negative in front of it, so I can safely assume it's going to be g and g. And then in order to get the second values, I am going to use that negative 4 at the end, and we're going to find all the factors for it. So to get to negative 4, I could do negative 1 and positive 4. I could do positive 1 and negative 4, or I could do 2 and negative 2. And now to decide which one, I need them to add to negative 3. So negative 1 and positive 4 equal positive 3. 1 and negative 4 is negative 3, and 2 and negative 2 is 0. So I'm going to choose the pair that gets me negative 3 because that matches. So let's plug them in. So that's positive 1 and negative 4. So now in order to find our zeros, we're going to set our equation to 0. And now we can break it up. 0 equals g plus 1, and then 0 equals g minus 4. So on the one hand, we're going to want to get g by itself. I'm actually going to flip this around to make our math look a little bit more consistent and a little bit more familiar. So we tend to see variables on the left, so I'm just turning it around. All right, so to get the plus 1 to go away, I'm going to do the opposite, so minus 1. So then g equals minus 1. On the other side, I have a negative 4, so I'm going to do positive 4s. So g equals 4. Now, g is a substitute value. It's not our real value, so I am going to plug in our original substitution back in. So g is actually equal to x squared. So let's put that back in. All right, so now we're going to take the square root to get rid of the squared on our x. So let's take the square root plus or minus, right? So we're going to do a plus or minus value because it's squared. So x is equal to, all right, so here's that other piece of information that we need to know, is that the imaginary number I is the square root of negative 1. And that helps us in this specific instance when we have a negative under a square root. So we're going to swap out the square root of negative 1 with I, and then we have a plus or minus in front. And on the other side, the square root of 4 is 2, so we have plus or minus 2. So that means that our zeros for this specific problem are positive I, negative I, 2, and negative 2. And from here, you can write out your function and solve it going forward. So now that we have those zeros, our zeros, if you recall, plus I, minus I, plus 2, minus 2, we can set up our equation completely factored. So q of x is equal to x plus I, x, minus I, x plus 2, and x minus 2. And now it would be in completely factored form using complex or imaginary values.